All right, so this video is going to go over pages 11 through 14 in your projectiles packet. So we're going to look at this conceptual question. So it says, at the same time that a high-speed bullet is fired horizontally from a rifle, another bullet is simply dropped from the same height. Which bullet strikes the ground first? So one of the things we talked about, remember, is that anything perpendicular to each other, so that means like horizontal versus vertical. Okay, if they're perpendicular to each other, that means they do not affect each other. So again, I know this can be a hard concept to think of, so let's pretend, let's do like a little stick figure guy here. And he fires a bullet from here. Okay, so that thing's going to head out. Now, this has to be perfectly horizontal. Okay, if you start angling up, that'll affect it. But that thing is going to start dropping instantly, okay, because gravity is pulling down on it. Now, if you were to take a same bullet, and we'll just do a different color for that. Okay, you're going to take a same bullet and drop it from the same height. Gravity is going to make it fall down at the same rate as it would if it's being shot. Okay, so sometimes as hard as this can be to see visually or think about it conceptually, they're actually going to strike the ground at the same time. Because, remember, horizontal does not affect vertical. If they're both dropping from the same height, okay, gravity is acting on them the same. Okay, so then horizontal has nothing to do with it. Okay, so this one's kind of tough, and there's plenty of videos. I even showed one in class. You can pull it up. You can pull up videos of something being dropped and launched, and you can see that for yourself. So the key thing here is that horizontal does not affect vertical, so therefore they would both strike the ground at the same time. Now, on this one right here, we have a plane. We'll just say it's going 300 miles per hour. Okay, and it's carrying a bomb. Where does the bomb hit the ground, and where is the plane when this happens? Okay, so if I were to ask you which one of these trajectories would it be, okay, I can go ahead and rule off some because I know it's not going to be A, okay, because if I'm launching something, it's not going to go backwards from where I'm at, okay, because if I'm carrying a bomb at 300 miles per hour, that bomb is also going 300 miles per hour in the same direction that I'm going, okay, and it's not going to just drop, so we can rule out B, because if the plane was sitting still, then yeah, but then it wouldn't be flying at all. So your options are between C and D. Okay, so when you drop something, it's never just a perfect line that just drops straight down like C. Okay, so it's actually what's going to look, it's going to look parabolic. Okay, so that means is when that thing's flying, it is initially only going horizontal. So that's why its arc, its path is a lot flatter at the beginning, because gravity is starting to act on it and starting to make it go faster and faster in the vertical direction. So as time goes on, that velocity starts creeping more into the vertical plane, because gravity is pulling it down. Okay, so if you want to know where that bomb would drop, it's going to land on part D. Now, if that bomb is going 300 miles per hour and that plane is going 300 miles per hour, that means if they both have to cover this same distance, they're both going to get there at the exact same time. So that means when that bomb goes off, that plane is going to be directly above where that bomb lands. Okay, so if you actually were dropping a bomb or a really big bomb, okay, the last place I'd want to be is right above it, okay, because your velocities were both the same, you both cover the same distance. So if you want to get away from that, that means you better either speed up or you better change your direction and go somewhere else. Okay, so we'll go on to the next page. Now, what we're actually going to do is we're going to talk about type 2 trajectory. So type 2 is where it's launched. So it looks like this. Like if you were to take a golf ball and launch it and stuff. So this is not a cliff problem anymore. So this is not where you roll off a cliff. Okay, that was type 1. Okay, so we're going to go over type 2. Okay, so it says on the graph, sketch the horizontal velocity as the ball passes through each point. Okay, so Vx, remember, it never changes. Okay, so Vx will always stay the same no matter what. Okay, so that means this little magnitude right here better stay the same the entire time. So I'm just going to try to draw the same size arrow every single time. Okay, so again, Vx does not change at all. It'll stay the same the entire time. Now, on the graph below, the sketch the vertical velocity. So remember, we have things where it's going to start affecting your velocity. We have gravity pulling on it. So if I were to kick something up in the air, okay, that velocity is going to start off strong. Okay, when it leaves my foot, that's the highest velocity it's going to get, because that's when all the velocity is purely there. Gravity hasn't really had a chance to act on it yet. But as you start going up, that velocity is going to start decreasing, okay, because gravity is pulling it down, and eventually it's going to stop at the top. So your Vy is going to be 0 at the top, because it has to stop. Otherwise, if it didn't, it would just keep going and never come back. Okay, so Vy is going to decrease as you go up. And then when it comes back down, what's going to happen is gravity is going to start pulling it down, so it's going to start speeding back up, just in the negative direction. Okay, so Vy is going to increase as you go down. Okay, now the reason why it's increasing, decreasing is because of gravity. So it's going to increase/decrease by 9.8 meters per second every second. So that is basically what 9.8 meters per second squared means. That just means your velocity is increasing or decreasing by 9.8 meters per second every second. So if you're going up, your velocity is decreasing by 9.8 meters per second every single second until it stops. And as you go down, it's going to increase by 9.8 meters per second every second until it hits the ground. Okay, so that is just summarizing Vy. So Vy does change because of gravity. Now, on the graph below, sketch the acceleration vector components. Remember, A is always the same. A is always going to be gravity. It's not going to change. It's always going to be negative 9.8 meters per second squared. So that's going to stay the same the entire time. Okay, so we're going to draw the same size arrows the entire time because that does not change. Now, an important thing to note is here that even when your velocity is 0 at the top, your A is still negative 9.8. Okay, if that A were to ever go to 0, that means we're all in trouble. That means gravity just disappeared and it's no longer there. Okay, so your velocity can be 0 all at once, but acceleration will always be gravity and it's always pulling you down. So you can be not moving, like right now I'm sitting in a chair, and gravity is trying to pull me down at negative 9.8 meters per second squared, because if you were to yank that chair out from under me, I'm going to fall at that rate. Okay, so which vectors remain constant throughout the trajectory? So remember we talked about Vx doesn't change. Okay, horizontal velocity stays the same the entire time. And acceleration does not change. Okay, and that is acceleration in the vertical component, okay, because it's always negative 9.8. Now, if I were to ask you things about Ax, now technically that would stay the same because it's always 0. Okay, there is no acceleration in the horizontal plane. So if I ever asked you anything about Ax, it would be 0 the entire time. Now, which vector is changing throughout the trajectory? That means the only thing that's actually changing is Vy, because that is due to gravity. Okay, so that's just kind of make sure you know that conceptually. Now, type 2 projectiles, on this one, we're not going to do any calculations yet. We're just going to kind of label some things and kind of make sure you're doing the right steps. So type 2 projectiles have both an initial horizontal and initial vertical velocity. So that means I have a Vx. And now what I do is I have an actual initial velocity. So remember, when we did cliff problems, we always said Vi was 0. Because you were on a cliff and then you rolled off of it, so you started not falling. Well, you were not falling and then you started falling, so that's why your initial velocity was 0. If you launch something in the air and you have an initial velocity of 0, that means it didn't even leave the ground, so it doesn't make sense anymore. So we are no longer using Vi as 0. So we'll talk about here in a second on how that's going to change. So when I launch a golf ball, so in this case we're going to draw an example. So we're just labeling stuff here. Okay, we're launching a golf ball. It's going to have an angle. Okay, so it's going to launch from the ground at some angle. And we're usually going to give you a velocity that goes with it. Okay, so if I say a golf ball is launched at 35 meters per second at 45 degrees, there's your angle, there's your given, there's your hypotenuse. Now, that V given, we're never going to use that besides to break up into Vx and Vyi. Okay, so we will always break that triangle up into Vx and Vyi. So we will never actually use this in any other questions besides breaking up into pieces. Okay, so that's just kind of a little tidbit for you. So we're going to have our trajectory. So that thing's going to launch. Okay, it'll come back down to the ground. So right here, that would be the max height. So at your max height, remember, velocity is going to be 0. Okay, now if I ask you what is the max height, okay, that would be your final position. So now what we're going to do is Vf is now becoming 0. So we're not saying Vi is 0 anymore. Now we're switching that 0 to Vf. So this is where you got to be really careful. If I'm talking about a cliff problem, so like this, and that thing's dropping off a cliff, then you can totally use Vi as 0. Okay, but if I'm talking about launching something like kicking a football, Okay, VI is no longer 0. Now VF is 0 at the top. And then if you want to figure out how far this is, remember that is called your range. That is how far horizontally it's actually hit. So because Vx is constant, the range can be found by, so remember, range is horizontal. There's only 3 things we ever care about horizontally. That is Vx, dx, and t. That's it. Okay, so my equation for that is simply Vx equals dx over t. So if I ask anything horizontal, there you go. Now, how do we solve this problem? So I'm going to show you some steps. The first thing I'm going to do is I'm going to break this triangle up into pieces. Okay, so that Vx, if I were to ask you what side of the Vx, okay, that would be your adjacent. If I were to ask you what side is the Vyi, that's your opposite. And your V given would be your hypotenuse. Okay, so if I want to find my Vx as my adjacent, I would see which trig function has adjacent and hypotenuse. Well, that's going to be cosine. Okay, so what we're going to do is, instead of me writing this where you do the whole hypotenuse, or what's going to look like is cosine of your angle equals adjacent over hypotenuse. And you have your angle, you have your hypotenuse. So instead of me writing it like that and having to do all the steps where you multiply both sides by the hypotenuse, we're just kind of skipping a step. Okay, so we're going to break that into pieces by doing Vx equals your V given, your hypotenuse, times cosine of your angle. Okay, and that's all you got to do. Okay, so we're just skipping that step and going right into multiplying both sides by the hypotenuse. Now, if you want to find Vyi, Vyi is your opposite, so I'd see which one has opposite and hypotenuse. Well, that's going to be sine. So you're going to do the exact same thing, but instead of cosine, you're just going to use sine of your angle. Okay, these two will always be the same no matter what. Okay, Vx is always going to use cosine because it's always the adjacent. Vy is always going to use sine because it's always the opposite. But these are the first 2 steps that I do every single time. Now, step 2, what I do next is once I know these 2, I can find my total time. Okay, so time can be found with multiple things. Okay, so time you can do Vx, dx, and t. That's if you have Vx, and that's if you have dx. You can also find it by doing daffy t. Okay, so it just kind of depends on what you have there. Okay, and then we'll talk about this on the next page. There's actually a shortcut on how to find time in type 2 projectiles. Okay, so there's multiple ways you can find time there, but that's usually our next step, is just to find the time. Step 3, if you want to find anything vertical, so that means if I ask you how high did it go, okay, you're going to do is you're going to set up daffy t. So every time you need to find something vertical, you should always set that up. Okay, and then anything horizontal, all you got to do, so horizontal, only thing you ever need is Vx, dx, and t. That's it. Okay, now a couple of tips before we end this video, just to make sure we're on the same page about some things. So remember, Vx doesn't change. No change at all. So if I ask you anything about horizontal acceleration, so ax, it's always going to be 0. Okay, because it's not speeding up, it's not slowing down, it's just staying the same. Now Vyi, or Vy, okay, velocity is going to change. Okay, so that will change because gravity is affecting it. So Ay is always going to be that negative 9.8 meters per second squared. Okay, and then max height, if I ask you anything about max height, okay, that means your Vf or Vy is going to be 0. Because remember, you have to launch it up, it has to stop at the top and then come back down. So the next video we're going to do is we're going to do more calculations, so we'll actually put this into play in the next video.